Hello everyone, my name is Shivam Kishor Patange and we are presenting this present project presentation on use of digital technology for micro irrigation system to improve water efficiency of irrigation sector using IoT, ML and cloud computing. Our group number is group number 25 and our members are Shivam Govindrao Mahalankar, Shivam Kishor Patange and Rushikesh Madhav Sagare. And we are guided by Mr. Sachin R Trankatwar in this project. We are thankful to him for guiding and being with us throughout this project. The domain. The domain of this project is IoT. IoT, Internet of Things, in agriculture refers to the use of connected devices and sensors to collect data and automate processes in agricultural operations. It involves the integration of digital technologies with farming practices to improve efficiency, productivity, and sustainability in agriculture sector. The IoT in agriculture are used for many means, such as precision farming, livestock monitoring, crop monitoring and management, farm management systems, supply chain optimization, smart greenhouses, and automated irrigation systems, on which our project is basically dependent on. The background, agriculture. Agriculture in India plays a significant role in the country's economy as in the primary source of livestock livelihood for a large percentage of the population. India has diverse agricultural sector due to its varied climate, soil types, and topography. It encompasses a wide range of crops, livestock, and other agricultural practices. This project generally focuses on monitoring and controlling action of irrigation in the farming. The motivation. Micro irrigation systems are designed to deliver water directly to the roots of the plants using low pressure, low volume irrigation methods. These systems are highly efficient and have been shown to be significantly reduce water use in agriculture and landscaping applications. The motivation for implementing a micro irrigation system is to improve water use efficiency and reduce water waste. Traditional irrigation systems such as flood irrigation and sprinkler systems can result in significant water loss owing to evaporation, runoff, and wind drift. Micro irrigation systems can reduce the water loss up to by 70%, resulting in significant water savings and increased crop yields. Despite the many advantages of crop irrigation systems, there is still room for improvement in terms of automation and smartness. The micro irrigation system is efficient but lacks in terms of deciding the right amount of water or when to start or stop the watering, making it completely manual, labor-based, and unsupervised. Due to the unsupervised use of water in irrigation, not only the crops suffer from excess watering, but also the water source undergo depletion. However, water is also wasted, which may lead to scarcity of water after a period of time. We are proposing a system which will be monitoring the soil contents such as moisture levels, but also will be able to control the motor switching upon such instructions. In this solution, we are employ technologies such as IoT, cloud computing, and machine learning to achieve the optimum performance of our project. The objective. The primary objective of this project is to develop the hardware system which will be able to read moisture values from the soil in real time and send them to the cloud platform using IoT technology, which will run decision tree machine learning model. The machine learning model was trained using the moisture values provided and achieved at least 95% of accuracy in predicting the soil condition from the provided values. The main objective of this project is to turn the watering motor on and off in accordance with the input provided in the real time. The secondary objective of this project is to provide a web-based control panel from where the user should be able to turn on or off the motor watering system as per his will. The flowchart. The flowchart of this project starts from the working of or the actual working of this project starts from the moisture sensor at the very bottom. The moisture sensor first collects the data and sends them to the cloud using NodeMCU ESP8266 microcontroller. The microcontroller uses Wi-Fi technology to connect with the public networks and send that data to the cloud platform. Our cloud platform is using a Linux-based Ubuntu operating system to process that values and run our machine learning model. We are primarily here using a decision tree machine learning model to decide whether the provided values are of wet or dry condition of the soil. Once decided, we will send back those values to the node MCU using the MQTT technology, and based out upon that, instruction or that information, we will either turn on the motor or off it. Next is working. Working of this project starts all the way from soil, collecting soil moisture samples and goes all the way up to the cloud platform, where the decision about switching of the watering motor is made. The operation can be divided into two parts as hardware part and software part. In hardware part, all the sensing and controlling actions using sensor and controllers take place, and in software part, all the decision making and communication between integral parts of the project, such as hardware, cloud platform, machine learning algorithms takes place. The hardware implementation. As we can see in the image given, the moisture sensor is connected to the node MCU, which is also connected with the 5-volt relay switch for controlling of the motor, watering motor. The sensor's VCC is connected to 3.3 volt of the node MCU, ground to the ground of the node MCU, and signal to the analog 0 A0 input of the node MCU. From here, we are collecting those analog values and sending them to the cloud using Wi-Fi. And at the same time, as you can see, for 5-volt relay switches, we have connected the VCC to the 5-volt of the 5-volt of the node MCU, ground to the ground of the node MCU, and the instruction or the actual switching signal is connected to the D5, that is digital 5 pin of the node MCU, which will be giving input to the 5-volt relay switch to either turn on or off the motor. This was all about the hardware implementation of this project. The next part comes with the software implementation. The software implementation starts with the cloud platform. Once we got all those moisture values from the hardware to the cloud platform, we will be using our cloud platform's Linux operating system to first filter them, then feed it to our decision tree machine learning algorithm, and create an output based upon it and send it back to our hardware. Here one catch is we are also using a Flask-based web application, which will be later used for manual operation of this project and the manual turning on or off the motor. The research and data collection. The research and data collection of this project was done from 13 April 2023 to the 16 April 2023. A total of 104,731 moisture values were recorded and used to train the decision tree machine learning algorithm. All these values are mapped with timestamp, the moisture level, and the irrigation status as either on or off. Here is given the timestamp versus moisture values graph. As we can see, the moisture values starts with near from 0.7 and goes all the way down to the 0.4. Then there occurs a sudden increase in moisture. At that time, the irrigation was started, and along with that, it continues. This was all about the data collection of this model. As shown in picture, this is the final working prototype of the project. As we can see, all the sensors, that is moisture sensor and 5-volt relay switch is shown in the figure in the photograph. And for the manual operation, we have given these links from where first we can go to those links and see our project report. And if we add port 8080 at the end, then we can go to the control panel. Here we can either type on and press enter to turn on the motor in manual mode, turn off to do it in a manual mode, or go auto for turning it on. It on in auto mode. Thank you.